y double prime minus y prime plus 2y is equal to 10 e to the minus x sine x. Gulp. Okay. So the input is this function 10 e to the minus, that's a decaying oscillation. You've seen those already on the computer screen if you've started your homework, if you've done problem 1 on your homework. It's a decaying exponential, and I want to find a particular solution. Well, let's find a particular, and the general solution. Find the general solution. Well, the main part of the work is finding the particular solution, but let's quickly, the general solution, let's find first the complementary part of it. In other words, the solution to the homogeneous equation, that's d squared minus d plus 2 no, let's not. I don't want to solve messy quadratics. Okay, we're going to find a particular solution. I thought it was going to come out easy, and then I realized it wasn't because I picked the wrong signs. Okay. So if you don't like it, just change the problem. I can do that, but you cannot. Don't forget that. So we want a particular solution, and our equation is this equals that. Now, let's complexify it to make this part of a complex exponential. So that the complex exponential that's relevant is 10 times e to the minus 1 plus I. You see that? X. What is this? This is the imaginary part of this complex exponential. So this is imaginary part of that guy. E to the negative x times e to the ix, and the imaginary part of e to the ix is sine x. The 10, of course, just comes along for the ride. Okay, what's our, well now since this is a complex equation, I shouldn't call this y anymore. By my notation, I like to call it y tilde to indicate that the solution we get to this is not going to be the original solution to the original problem, but you'll have to take the imaginary part of it to get it. So we're looking now for the complex solution to this complexified equation. Okay, what is it? Well, the complex particular solution I can write down immediately. It is 10, that of course just gets dragged along by linearity, times e to the minus 1 plus I times x, and it's over this polynomial evaluated at this alpha. So just write it down with have faith. So what do I get? The alpha is minus 1 plus I. I square that because I'm substituting this alpha into that polynomial. The reason I'm doing that is because the formula tells me to do it. That's going to be the solution. Okay, so it's minus 1 plus I, the quantity squared, minus 1 plus I, plus 2. All I've done is substitute minus 1 plus I for d in that polynomial, the quadratic polynomial. And now all I want is the imaginary part of this. The imaginary part of this will be the solution to the original problem, because this was the right-hand side, was the imaginary part of the complexified right-hand side. Okay, now let's make it look a little better. Yp tilde. Clearly what we have to do is something nice to the denominator. So I'll copy the numerator. That's e to the minus 1 plus I, x. And how about the denominator? Well, again, don't expand things out because it's already this long, and what's the point of making it this long? You want to make it this long, right? Okay. Then there's room here for one real number and another real number times I. There's no more room. Okay, what's the real number? Okay, we're looking for the real part of this expression. So just put it in and keep it mentally. So minus 1 squared, that's 1, plus I squared, that's minus 1. 1 minus 1 is 0. I can forget about that term. This term gives me plus 1 for the real part, plus 2. The answer is that the real part is 3. How about the imaginary part? Well, from here, there's negative 2i, from expanding that out by the binomial theorem or whatever you like to call that, minus 2i minus I makes minus 3i. Is that right? Minus 2i minus I minus 3i. So it is 10/3. And now in the denominator I have 1 minus I. I'll put that in the numerator, make it 1 plus I, but I have to divide by the product of 1 minus I and its complex conjugate. In other words, I'm multiplying both top and bottom by 1 plus I. And so that makes here 1 squared plus 1 squared is 2. That takes care, and now what's left is e to the negative x times cosine x plus I sine x. Now, of that, what we want is just the imaginary part. Well, let's see. 2 goes into 10 makes 5, so that's 5/3. So we're practically at our solution. The solution then finally is going to be yp is the imaginary part of yp tilde. And what's that? Well, what's the coefficient out front, first of all? It's 5/3. So let's pull out the 5/3 before we forget it. And we'll pull out the e to the negative x before we forget that. And then the rest is simply a question of seeing what's left. Well, it's 1. I want the imaginary part. So the imaginary part is going to be 1 times cosine x. And then the other imaginary part comes from these two pieces, which is 1 times sine x. And that should be the particular solution. Notice that the work, most of the work is not getting this thing, it's turning it into something human that you can take the real and imaginary parts of. If we don't like this form, you can put it in the other form, which many engineers would do almost automatically. Make it 5/3 e to the negative x, and what will that be? Well, you can use the general formula if you want. Remember, cosine, there's the two coefficients are 1 and 1, so it's 1 and 1. So this is the square root of 2, so it is times, this part makes the square root of 2 times cosine of x minus pi over the angle. This is the phi, so that's pi over 4, minus pi over 4.